Okay, let's just draw a picture of these. So 0.7 there, 6.5, so 6.5 somewhere there, 5.2 about there, and -1, 4 about there. And we've got to show that that is a rectangle. So if I was to draw that in, well, if I draw it like that, for it to be a rectangle, those two lengths must be exactly the same. So that's 0.7. That one there was 6.5. That's 5.2. And that's -1, 4. And so if I show these two lengths are the same, do this bit in red. That goes down a bit and goes across. And it goes from 0 across to 6, so that's 6. And it goes from 7 down to 5, so that's 2. So that length is the square root of 2 squared plus 6 squared, which equals root 40. Well, you can simplify that, take out a 4. But this one here goes down 2, from 4 down to 2, and goes across 6. So lengths both equal. So it's done that bit. Now I'll do the next bit in green, because I could show that those two lengths are the same, but then it could be a parallelogram. What I need to do is show that this and this, that is at right angles to the initial line. So it's about a gradient. So gradient of that bit there. So gradient is change in y over change in x, and it goes down 2, so it's -2 over and goes across by 6, which equals -1/3. And the gradient of this bit here, gradient, and this one goes, it's got to go from -1 to 0, so that's 1, and it goes from 4 all the way up to 7, so that's 3. So gradient is 1 over, no it's not, it's change in y. Sorry, it goes up by 3, so it's 3 over 1, which equals 3. And to show that they're perpendicular, then we have to have m times m1 equals -1, so, or m whatever. So 3 times by -1/3 does equal -1, therefore they are perpendicular. And therefore we've got a right angle there. We've got the blue line here, it's the same length as the blue line here, therefore it's a rectangle. Well, technically, I suppose it could be a square, but a square is a rectangle, so I've still done it. If you'd said it wasn't a square, you'd have to actually work out the length of that line there. As you can see, that's not root 40 anyhow. So picture helps, but you have to go through both bits. Lengths both equal, and they are perpendicular. You could have done some work with diagonals, but anyhow, that's that done.